Hi students, good morning all of you. Hope you are all doing good. Welcome to lecture 41 in this course, and at present we are discussing the unit definite integrals, and our today's topic is graphical transformations. Hope you have watched the previous lectures in definite integration, and from this lecture onwards I will be discussing the applications of definite integration, namely finding area under the given curve. As a prerequisite to that, we will be discussing some elementary functions and their graphs, and we will be discussing some transformations of the graphs. The next topic that I am going to discuss is graphical transformation. So in this lecture, I will be discussing 5 graphical transformations. Let us discuss one by one. Here is the first graphical transformation, namely the vertical shift graphical transformation. Let us understand what is this transformation. So here is the statement: when a function f of x transform to f of x plus or minus a, where a is greater than 0, then the graph of f of x shifts vertically upwards or vertically downwards. Let us see, when does the graph shifts vertically up, when does the graph shifts vertically down. Here is the statement: when f of x transform to f of x plus a, then the graph of f of x shifts vertically up by a units. When f of x transform to f of x minus a, then the graph of f of x shifts vertically down by a units. Let us understand graphically these two statements. Here is the example. The first example I am considering is the parabola y is equal to x square. So here my f of x is x square. Now I would like to plot the graph of y is equal to x square plus 2. So as per the statement, so the graph of x square shifts vertically up by 2 units. And this graph is represented by the orange color curve y is equal to x square plus 2. You can see that this graph is shifted vertically up by 2 units. Okay. Now I would like to plot the graph of y is equal to x square minus 2. So as per the statement, this graph shifts vertically downwards here. So in this case it is vertically up, in this case it is vertically down. So this is shifted vertically down by 2 units. So y is equal to x square minus 2 is represented in the green color curve, which is shifted downwards. The graph of y is equal to x square plus 2 is represented in the orange color, which is shifted 2 units upwards. Let me explain one more example here. Here I am considering the modulus function. So the function I am considering here is y is equal to f of x is equal to mod x. Okay. Now I would like to plot the graph of y is equal to mod x plus 2. As per the statement, the graph shifts vertically up by 2 units, which is represented by the orange color curve. So this is y is equal to mod x plus 2. So here it is shifted by 2 units. Okay, in this case it is shifted vertically up. Now the graph, I would like to plot the graph of y is equal to mod x minus 2, and as per that statement this graph shifts vertically downwards. Okay, and this is represented by the green color curve. Okay, so in this case it is shifted downward direction. Okay, hope you have understood the vertical shift graphical transformation in with these two examples. Now here are the exercise problems. Now plot the graph of y is equal to x cube plus 3. You know the graph of y is equal to x cube, and y is equal to x cube plus 3 means it takes the vertical shift by 3 units. And the second example is y is equal to 1 plus x square, and the third exercise problem is y is equal to e power x plus 3, and the fourth exercise problem is sin x. Try out these graphs on your own. Here is a next graphical transformation, namely horizontal shift. Let us try to understand this transformation. When a function f of x transform to f of x plus or minus a, where a is a positive real number, then the graph shifts horizontally right or horizontally left. Let us see when does the graph shifts horizontally right or horizontally left. When f of x transforms to f of x minus a, then the graph of f of x shifts horizontally right by a units. When f of x transforms to f of x plus a, then the graph of f of x shifts horizontally left by a units. Let us understand this graphical transformation with the help of an example. So here are the examples. Here is the first example. The example which I have considered here is y square is equal to x, and of course you can see it is represented by the orange color curve. This is the graph of y square is equal to x. Now I would like to plot the graph of y square is equal to x minus 2. So as per the statement, the graph shifts horizontal right by 2 units. And you can see from the graph, this is y square is equal to x minus 2, and it is shifted horizontally right by 2 units. So this distance is 2 units. Okay, now I would like to plot the graph of y square is equal to x plus 2. Okay, as per that statement, the graph shifts horizontally left. Okay, and you can see this curve is represented in the blue color, and you can see this graph shifts left direction, okay, in the left direction by 2 units. Okay, so this is the graph of y square is equal to x plus 2. Hope you have understood this horizontal shift graphical transformation. Okay, I think in the name there is a correction. This must be horizontal shift. Okay, here is the next example. Y is equal to sin x. So here I have considered y is equal to sin x function. Anyway, you know the graph of the sin x function. It is represented in the orange color curve. Okay, now I would like to plot the graph of y is equal to sin of x minus pi by 4, and you can see it is represented in the green color curve. So it is represented in the green color curve. You can see the difference. Okay, it is shifted horizontally right direction by pi by 4 units. Okay, the graph of y is equal to sin of x minus pi by 4 is represented in the green color, which is shifted right by pi by 4 units. Now let us plot the graph of y is equal to sin of x plus pi by 4. Okay, in this case the graph is moving horizontally right. Now y is equal to sin x plus 4 means in this case the sine curve shifts horizontally left by pi by 4 units, and it is represented in the blue color curve. Okay, this is represented in the blue color curve, and you can see it is shifted horizontally left. Okay, so I hope you have understood the graphical transformation horizontal shift with these two examples. Now try out some exercise problems. Here is the first exercise problem. Y square is equal to x plus 3, y is equal to x minus 2 whole square, and y is equal to cos of x minus pi by 4, and y is equal to mod x plus 2. Try out these graphs on your own, and here is our next graphical transformation, namely vertical stretch and vertical shrink. Let us try to understand this transformation. When a function f of x transforms to k into f of x where k is greater than 0, then the graph of f of x stretch vertically or shrink vertically. So when does it stretch vertically and when does it shrink vertically? Let us understand. When f of x transforms to a into f of x where a is greater than 0, then the graph of f of x stretches a times along y-axis or in the y direction. When f of x transforms to 1 by a into f of x where a is greater than 1, then the graph of f of x shrinks a times along the y-axis or in the vertical direction. Let us understand the vertical stretch and vertical shrink. Vertical stretch I explain here. So vertical stretch on this object means I have to apply the pressure in the vertical direction in these two opposite directions. Okay, whereas vertical strain means vertical shrink means I have to apply the pressure in these two directions, in these two opposite directions. Okay, let us understand this graphical transformation with the help of an example. Here is the first example. I am considering the cosine curve y is equal to cos x, and on the same graph we have plotted y is equal to 2 into cos x and y is equal to half into cos x. Okay, so as per the statement, this cos x is multiplied by a constant a which is greater than 1, so the graph will be stretched in the vertical direction. Okay, if you observe, the graph of y is equal to cos x is represented with the orange color curve, so it is in the middle. Okay, now in order to get y is equal to 2 cos x graph, I have to stretch this graph vertical in the vertical direction. Okay, then you will be getting the green color curve. This is y is equal to 2 into cos x. Now if you observe, y is equal to half into cos x. Okay, so how do I get this curve? I have to apply the force in these two directions on this particular curve. Then I'll be getting this blue colored curve, that is y is equal to half into cos x. It actually shrink in the vertical direction. Okay, now let me explain one more example. Let us understand the same transformation with one more example. Here I am considering the graph of y is equal to x square. Okay, now let me consider y is equal to 4x square and y is equal to 2x square. Now as discussed, this function gets multiplied by 4 units and this function gets multiplied by 2 units. Anyway, the graph of y is equal to x square graph is represented in the green color curve. Okay, that means y is equal to 2x square means I have to apply a vertical stretch in this direction. So it has gone and reached here. Okay, because if at all I am applying some force, there will be a limited force. So say for example, to get this graph I am applying 2 newtons of force in the vertical direction. In order to get this graph I am applying 4 newton force, let us say. So based on the force you apply, it will stop here and we will be getting this kind of curve. So y is equal to 4x square curve is represented by this purple color or violet color, and y is equal to 2x square is represented by it looks orange color. Okay, so this is y is equal to 2x square and this is y is equal to 4x square. Anyway, it is shrinking vertically. This is what we have to understand. Now if you look at y is equal to half into x square graph and y is equal to 1 by 4 into x square graph, then there will be a vertical shrink. That means a force will be applied, a pressure will be applied on this graph in this direction. Then in that case the graph is stretches horizontally and it reaches here. That's why these two graphs looks little down when compared to the above two graphs. Okay, so this is the graph of y is equal to half x square and this is the graph of y is equal to, the y is equal to 1 by 4 x square is represented in the blue color curve. Okay, and y is equal to half x square is represented in the orange color curve. Okay, I hope you understood the graphically what is a vertical shrink and what is a vertical stretch along vertical stretch and vertical shrink of a particular graph. Okay, here are some exercise problems. You try out on your own. Y is equal to 3 into sin x, y is equal to 2 into x square, y is equal to root 3 into sin x, and y is equal to 8 into x square. Try out these exercise problems on your own and check out your answers with some or the other graphing calculators. Hope you have understood this transformation. Here is our next graphical transformation, namely horizontal stretch and horizontal shrink. Let us try to understand this transformation. When a function f of x transforms to f of kx, where k is greater than 0, then the graph of f of x stretches or shrinks in the horizontal direction. So when does it stretch and when does it shrink horizontally? Let us try to understand. So when f of x transform to f of ax, where a is greater than 1, then the graph of f of x shrinks a times along the x-axis or in the horizontal direction. When f of x transform to f of x by a, where a is greater than 1, then the graph of f of x stretches a times along x-axis. So let us understand the horizontal stretch and horizontal shrink. Horizontal stretch means what? That means now I have to apply the pressure in this direction. This is horizontal stretch. Okay. Now let us understand the horizontal shrink. That means I have to apply the pressure in this direction. This is horizontal shrink. Okay, so when does it shrink? When when x is replaced with ax. And when does it stretch? When x is replaced with x by a. Let us understand this transformation with the help of examples. So here is the first example. The graph of y is equal to sin x. Okay. So here I am considering the graph of y is equal to sin x and y is equal to sine of x by 2. So y is equal to sin x is represented by the orange color curve, and the graph of y is equal to half into sin x is represented by the blue color curve. So basically, since x is replaced with x by 2, obviously there will be a stretch. Okay, that means this curve is plotted in the interval 0 to 2 pi. So this curve is plotted, okay, sorry, I think it is plotted from in the interval 0 to 4 pi. Now if you observe the orange color curve, it has completed 2 cycles. Okay, from here to here one cycle and here to here one more cycle. Whereas if you observe sine of x by 2, it has completed only one cycle. That means it is stretched in the horizontal, that the graph of sin x is stretched along the horizontal direction. Okay, hope you have understood this. Okay, now let us understand one more example. Again, the same graph is plotted in the interval 0 to 4 pi. If you observe the graph of sin x and the sin 2x graph, the sin x graph is represented with orange color curve. So if you observe that it has completed 2 cycles here. Okay, 2 cycles from 0 to 2 pi. One cycle is from 0 to 2 pi and other cycle is from 2 pi to 4 pi. This that means sin x have completed 2 cycles in the interval 0 to 2 pi. Whereas if you look at the graph of sin 2x, it has completed, this is one cycle, this is one cycle, okay, and this is another cycle, this is 2 cycles, and this is the third cycle, and this is the fourth cycle. That means y is equal to sin 2x have completed 4 cycles. Okay, so and you can see the graph of sin 2x. In order to get sin 2x graph, the graph of sin x gets compressed. Okay, so the orange color graph gets compressed and you will be getting the blue colored version, blue colored curve, sin 2x. Okay, let us understand with the help of one more example. So here I am considering y is equal to mod x graph. Okay, y is equal to mod x is represented by the orange color curve. Now y is equal, if you look at the graph of y is equal to mod x by 2, as per the statement, this graph y is equal to mod x has to stretch horizontally. So if you stretch this graph horizontally, then you will be getting this kind of graph. Maybe this graph will go like this. Okay, so this y is equal to modulus of half x is represented by the blue colored curve. Now if you observe the graph of y is equal to mod 2x, okay, now this graph is shrinked horizontally. That means the pressure is applied in this direction. That means in this direction if I apply, then I am getting this green color curve. Okay, so horizontal stretch means away from the graph, and horizontal shrink is above from the towards the graph. Okay, right. This is the graph of y is equal to mod x by 2. Mod x by 2 is represented by the blue colored curve, and y is equal to mod 2x is represented by the green color curve. Hope you have understood graphically what is a horizontal stretch and horizontal shrink. Here are some exercise problems. Y is equal to 4x square, y is equal to cos 2x, and y is equal to 1 by 4x. Try to plot the graphs on your own and check with any graphing calculators. Okay. Here is our next transformation, namely reflection about x-axis and reflection about y-axis. When does the graph reflects about x-axis? When does the graph reflects about y-axis? Let us try to understand. Here is the first statement. When f of x transform to minus f of x, then the graph of f of x reflects about x-axis. Let us try to understand this statement. Suppose on the original graph you plot using these points x comma f of x. Now you have to plot the graph with x comma minus f of x. Okay, so this is what it means, because your new function is minus f of x. Now let me explain graphically. So this is x-axis and this is y-axis. Let us consider the point x comma f of x lies in the first quadrant. Then where does the point x comma minus f of x will be? So it will be exactly in the fourth quadrant, x comma minus f of x. So it is clearly reflection about x-axis. Now suppose you have a point here x comma f of x in the second quadrant, then x comma minus f of x will be exactly in the third quadrant. It is again a reflection about y-axis, sorry, x-axis. So I hope you understood why the graph reflects about x-axis when you transform f of x with minus f of x. Okay, now let us understand reflection about y-axis. What is the change that you have to make? When f of x is replaced with f of minus x, then the graph of f of x reflects about y-axis. That means you have the point x comma f of x on the original graph. Now you have to make the graph with points minus x comma f of minus x. That is nothing but minus x comma f of x only. Okay, so you have to plot the graph. So in the original graph you have the points x comma f of x. Now in the new graph you have the points minus x comma f of x. That means what? Graphically, suppose I have a point x comma f of x here, then where does minus x will be? If x is here, then the minus x will be here, and which is at the same distance f of x. So your x comma minus x comma f of x will be in the second quadrant. That is, it is nothing but reflection about y-axis. Suppose the same point lies here, x comma f of x, then immediately this point will be in the third quadrant, x comma f of x and vice versa. So that's why if you have graph with these points, you will have a graph with these points. That means it is reflection about y-axis and vice versa. Hope you have understood the geometrical meaning of it. Let us try to understand graphically with some examples. Here is the first example, y is equal to x square. You have the points here, y is equal to x square graph is represented by the blue color curve, and y is equal to minus x square graph is represented in the orange color curve. Anyway, it is clear reflection about x-axis. Now we are considering the graphs of y is equal to log x and y is equal to minus log x graphs. Now if you observe, the y is equal to log x graph is represented in the blue color. Okay, so beyond 0, after 0 it goes in the negative direction. As x approaches 0, then log x approaches negative infinity here. So some part is above the x-axis and some part is below the x-axis. Now upon reflection, the below part will go above, and the above part will come below. Okay, that's why the graph looks here. The graph looks like this. Okay, I hope you have understood the reflection about x-axis. Now let us have a look at reflection about y-axis. Now here I am considering the example y is equal to e to the power x. The graph of e to the power x is represented in the blue colored curve. Now I have to find out the graph of e to the power minus x. The graph of e to the power minus x is represented in the orange colored curve. Okay, so it is clearly the reflection about y-axis with the help of the above statement. So some part is in the first quadrant and some part is in the second quadrant. Upon reflection, it goes in the opposite direction. This part will come here and this part will go here. So, and you will be getting this graph. Okay, here is our next example, y is equal to log x graph. So this is y is equal to log x graph and y is equal to log of minus x graph. So some of you might have a doubt that log minus x cannot be defined, but you have to observe the domain there. So log of minus x is defined when x is negative, because minus of minus it is going to be plus. So if you observe the graph carefully, y is equal to log x is represented with the orange color curve, and that of y is equal to log of minus x is represented by the pink magenta color curve. Okay, and of course you can see that log of minus x is defined only in the negative x values, and whereas y is equal to log x is defined only for the positive x values. Okay, I hope you have understood these two examples. Okay, here are some exercise problems to you. Y square is equal to minus x. Try to plot the graph of this. And y is equal to minus 1 by x, and y is equal to minus x cube, and y is equal to minus sin x. Try to plot the graphs on your own, because anyway you know some basic graphs. These graphs are given based on those basic graphs only, and verify your answers with the help of a graphing calculator. Hope you have understood these graphical transformations. Here I would like to discuss examples of some graphical transformations. Here is the first example. You are asked to sketch the graph of y is equal to 2 minus x square. So we'll sketch the graph of this in 3 steps. First we will draw the graph of y is equal to x square, and then we will draw the graph of y is equal to minus x square, and then we will draw the graph of y is equal to 2 minus x square. Here is the first step, the graph of x square. This is a parabola that we know it, and y is equal to minus x square is a reflection about x-axis. So that's why the graph of parabola looks like this. So it is inverted. Okay, now we'll draw the graph of y is equal to 2 minus x square. So 2 minus x square means you can see that there will be a vertical shift upward by 2 units. So this is the required graph of y is equal to 2 minus x square. Here is our next example. You are asked to sketch the graph of y square is equal to 2 into 5 minus x. Here we will sketch it in 4 steps. First we will consider the graph of y square is equal to x. Then we will consider the graph, then we will sketch the graph of y square is equal to minus x. Then we will draw the graph of y square is equal to minus 2x, and then finally y square is equal to minus 2 into x minus 5, because this can be written as minus 2 into x minus 5. Okay, so let me show you the first graph, that is y square is equal to x. So this is how the graph looks like. This is a parabola. We have seen this graph already. Now we will plot the graph of y is equal to minus x. So y square is equal to minus x will be a reflection about y axis. Okay, now we will sketch the graph of y square is equal to minus 2x. It is a horizontal shrink of the graph. If you have a horizontal shrink, obviously it will grow up vertically. Okay, anyway, the graph of y square is equal to minus 2x is visible here. Now the final thing, y square is equal to minus 2 into x minus 5. So y square is equal to minus 2 into x minus 5 means there will be a horizontal shift in the right direction. So you can see that it is horizontally shifted, because here you can see it is 0, and if you observe here it is 5. So from 0 to 5 it is shifted horizontally 5 units. This distance is 5 units. So this is the graph of y square is equal to minus 2 into x minus 5, or 2 into 5 minus x. Hope you have understood this example. Here is the next example. Sketch the graph of y is equal to x square plus 2x plus 2. First you have to complete the square. So y is equal to x square plus 2 into 1 into x plus 1 square minus 1 square plus 2. So after completing the square, we have got this particular form: y minus 1 is equal to x plus 1 whole square. We draw the graph, we sketch the graph in 3 steps. First we will be considering y is equal to x square. Let me show it here. First we will sketch the graph of y is equal to x square, and then we will show you the graph of y is equal to, we will draw the graph of y is equal to x plus 1 whole square. Then finally we will draw the graph of y minus 1 is equal to x plus 1 whole square. In 3 steps we will sketch this graph. Okay, first the graph of y is equal to x square, no reflection about x axis, and y is equal to x plus 1 square. It is horizontally, the graph of x square gets translated horizontally left by 1 unit. Then from there you sketch the graph of y minus 1 is equal to x plus 1 whole square. Then there will be a vertical shift upward by 1 unit. Okay, so this is the required graph or required sketch. Here is one more example. Sketch the graph of 2x square plus 4x plus 4. So again you have to complete the square. So after completing the square, we have got this particular step. Okay, so first we will draw the graph of y is equal to 2x square first. So y is equal to 2x square and y is equal to x square, if you compare, then there will be a vertical stretch. That's why I have drawn the graph y is equal to 2x square directly. Then we will draw the graph of y is equal to 2 into x plus 1 whole square. This is a horizontal, the graph is shifted horizontally left by 1 unit. Then the graph will be shifted vertically up. Y minus 2 is equal to 2 into x plus 1 whole square graph. Okay, this is how this graph can be sketched. Here is the next example. Sketch the graph of 10x minus x square minus 16. So first we have to complete the square and we have to get this final form. Y minus 9 is equal to minus of x minus 5 whole square. First we will sketch the graph of y is equal to minus x square, and then horizontally left and vertically up. So horizontally left, that is y is equal to minus of x minus 5 whole square. I think, okay, in this case horizontally right direction, because x is replaced with x minus 5 whole square, and afterwards it goes vertically upward direction by 9 units. So this is the sketch of the required graph. Hope you have understood these examples.